Hi, everyone. My name is Raquel with adtmag.com, and I'd like to thank you all for joining us. The topic of today's webcast is Cracking the Case, How to Migrate from Monoliths to Microservices, sponsored by Lightstep. Before we begin, I'd like to cover a few housekeeping details. There will be a Q&A session towards the end of today's presentation, so please type any questions that you may have in the Q&A box. Lightstep has also provided some great resources that correspond with today's webinar, so please take a moment to check those out. And additionally, this webcast is being recorded, so keep an eye out for a link in your email so you can rewatch the presentation or share it with a colleague. Now I'd like to introduce you to our speaker. Today we are joined by Stephanie Baum, a software engineer at Lightstep. So we are in great hands today, and with that, I'll pass the time over to Stephanie to get us started.
Awesome. Thanks so much for that great introduction. So welcome, everyone. Thanks for joining me. I'm Stephanie. I'm a software engineer at Lightstep. Previously, I actually was on our solution architecture team. And then before that, I was a senior software engineer at Zachary, building serverless applications. And prior to that, I actually worked with large companies on modernizing their architecture in Accenture's lightweight architecture group. So I'm pretty familiar with the space and have been for a while. I really do love these migration problems and trying to understand what the best architectures are for splitting out your monoliths and distributed architecture in the cloud. It's definitely a passion of mine. So thanks so much for joining me on this talk. Just a quick agenda here. So first, I'm going to walk through a general service migration strategy with a kind of contrived but basic example architecture. And then after that, I'll talk about observability and how to use that to de-risk a migration. And then we'll talk about what modern observability for microservices looks like and have some Q&A. So this is our example monolith here. Basically, what we're trying to do is split this out into a microservice, and we have a monolith that serves several different endpoints here. So we've got the API endpoints, and that's in orange. And then we've got the external calls to other infrastructure services in green. And then all of this is within one container. It looks like someone from the audience actually says they can hear really loud feedback. Is that from me or?
I'll still hear the background noise. Please just refresh your page.
Cool. Thanks for addressing that. Okay, so this is our example monolith, and what we're trying to do is split out payments into its own microservice and integrate with a new third party. We could want to do this for various reasons. Let's say the payment system is really old and doesn't meet our security standards, or it doesn't scale well for us, for example. Here's our goal state. So we want to split payments out into its own service separately from our monolith, with no downtime to upstream services and end users. So what does no downtime mean? Well, it literally means we have no revenue loss, and users will always be able to access our payment service, even if it's pointing to the old monolith or the new service, until we completely migrate these endpoints over. So this is just like an example, basically, to talk through how you would actually do a migration. So this is usually how I approach migrations. Basically, we start with a scenario. So current payments are handled in the monolith. We want something horizontally scalable. We want to integrate with a third-party API. We want it to operate asynchronously from the rest of the stack, so kind of like its own thing with its own state that is separate from the rest of the monolith. So we don't want the monolith to rely on the state of the payments service at all. So basically, we need to define our must-haves up front. More scalability, more reliability, and that third-party integration, no downtime. I think the main tip here is to define must-haves immediately and start thinking about SLOs immediately before you even begin your design. So more on how SLOs work. So basically from experience, I've learned that everyone has tons of different opinions on SLOs. These are service level objectives, and no one kind of knows the best way to define them. There is a lot of approaches here, but here is basically my tips. So when you're defining a service level objective, start with the services upstream that rely on your service and services downstream that you rely on. And that's to protect your team from blame if something goes wrong. You want to be able to monitor those downstream services that your team is relying on for the new service that you're building so that you know when those downstream services go down, that it's not your team's fault, it's the downstream that is causing problems. So another tip here is to define executive SLOs as well based on critical end user business operations. So what's actually going to cause the loss of time, money, or users if it breaks. And you can use observability that leverages tracing and metrics to measure and define end-to-end SLOs. So I'm going to give some examples of service level objectives. For example, let's say we want 99% uptime. That's a service level objective. Say we want to monitor our downstream and basically alert if our downstream has an error rate over, let's say, 5% or something like that. So over 5% of requests to our downstream service are failing. That's another SLO that you could have. And service level objectives, service level indicators, service level alerts, they're all kind of bundled together in this idea. So here is just basically an illustration to further define what I just talked about. So we have the end user state here where a user is clicking a pay button. And this is our critical business operation SLO. It's defined here. So basically, alert when clicking the pay button on a validated payment option's error rate is greater than 1%. That would be an SLO here that defines when I'm losing revenue and is basically a critical alert for this section of my system. Then we've got service level SLOs. So an example here would be to alert when the third-party payment, alert when the pay endpoint's P99, which is like the 1% of requests, are above 5 seconds. So we could say that's a service level SLO because this is basically encapsulated by our new payment microservice here, and it will affect the end users, but it's something that our team might be able to control and want to alert on because that 5 seconds wait time for that payment endpoint is probably unacceptable to upstream services. And then we've got provider or infrastructure SLOs, which kind of exist here on the external calls. So we probably want to call the third-party service, for example, or an authorization service, or the cart storage, or whatever external calls here. We want to have monitoring and SLOs on these calls so that we can keep track of when they're actually failing. So an example here would be to alert when the third-party payment service error rate is greater than 1%, for example. So hopefully this kind of gives you an idea of what service level objectives are and why they're important. So even if we haven't fully designed our microservice yet, it's great to start from this perspective because we can basically align our goals with this as we're designing our system. What are the what are the service level goals here that we want to meet when we're designing our microservice, and how is that going to influence the end user business value? So now going down to the more operational level of migration strategy here, one thing that you want to do is make sure that containerization configuration management, permissions, and CI/CD is set up in a repeatable way for new microservices as you're spinning them up. So the first time that you make a new microservice, you'll probably have to figure this out if you haven't already. But then after that, you probably want to have a more repeatable way of doing this so that basically it kind of makes the whole process a lot smoother. But this is definitely like a big upfront hurdle. You also want to address any security must-haves and do rough cost analysis upfront. Security concerns can be a little bit different for microservices than monoliths, just because there's a lot more moving parts and there might be a lot more external calls over the wire and things like that. And this may seem obvious, but I have a tip here. Always use a familiar programming language for the service unless there's a good reason not to. So in a lot of more enterprise-y type companies, I see some rogue teams happen sometimes. Essentially, they'll pick a new programming language that no other team is using for their microservice. I would recommend against doing that unless there's a really good reason for it. And that's just because when you are creating a new service for the first time, you don't want to add any additional hurdles there on top of that. Just because you're following a microservice architecture doesn't mean that each team should be able to just do their own thing. And that's just my personal opinion, but it definitely makes debugging and things like that a lot easier. So one thing that always comes up, at least recently, as we have entered the serverless and Lambda, age, people are really into serverless and Lambda. And I personally think that it's not always the right answer. So when should you use it? It depends how familiar your team is with the technology and how complex the business logic is. So if the business logic that your service is going to handle is going to take longer than 30 seconds sometimes to process, then you should consider using a short-lived container instead or microservice. So sometimes it makes sense to jump from monoliths to serverless completely, especially when you're doing basically like CRUD operations or simple things that could be accomplished in less than 30 seconds. Then you definitely could consider basically jumping straight to serverless for some of your endpoints from your monolith. But if you are doing something that is more complex and longer lived, then definitely consider a microservice or a short-lived container. So let's talk about the API contract now. This is definitely a critical piece in any engineering design for a new service. Defining how that service is going to be exposed to the outside world, to upstream services, what kind of requests does it need to handle to support any new functionality. So this is usually something that we definitely start with up front in the engineering design for migration. I think it's really important here to understand and diagram out existing behavior that will be migrated out of the monolith and understand current performance limitations and basically add these to that must-have list that we talked about earlier. And also, a great point here is to use some kind of API modeling like Swagger if you want to enforce API stability. Swagger is a great tool for that. It allows you to basically even embed your API contract inside your code, which further helps enforce API stability and catches changes or regressions. And you can also use observability tools that leverage tracing to understand current performance limitations and bottlenecks. And those can also help you understand basically where those code paths are going in your monolith and which code paths you want to actually migrate out. There might be some forgotten code paths that you're missing, for example, and tracing can help you visualize that. So next, let's talk about Dataflow and data models. So in our example, what exactly is the new logic and data model for the third-party service we're integrating with? And in general, what external infrastructure are we relying on in our new service? So that's really what we want to address here with Dataflow and data models. And basically, we also want to plan for upfront risk. So de-risking activity here could fall under benchmarking, throughput analysis of the current system, management plans and playbooks for any new external infrastructure or services. But when it comes to data flow, we want to understand what is the new data model on that external system, and how are we going to transform the current request over to basically integrate with that third-party service. We also want to create a plan here for how to migrate basically those old endpoints over to the new ones, and we want to plan for that plan to fail. So basically, it's great to have a backup if this doesn't work out initially, especially if this is your first run with microservices. So things to think about here: what's the percent of traffic, essentially, that is going to be pushed to the new microservice over the monolith? And do we want to do one endpoint at a time in this migration? And when do we want to consider the migration completely done? Basically, how do you make sure that there are no requests coming into that old endpoint in the migration or in the monolith, basically? So, for example, how do you detect when all of the requests are going over to the microservice? How do you detect when any other external parties that are calling this API have effectively switched over to the microservice? Sometimes this is simple and sometimes it's not. And that's where observability can help out there. Another thing here, obviously, is how do you roll the microservice back if you introduce a new endpoint that causes things to fail? And this is just really going back to the challenges here with microservices. As you continue to add more microservices into your system, you start getting a diagram like this where basically your team controls the microservices that you created. Maybe it's one or maybe it's a few, but your microservices are calling other external infrastructure, whether that's a third party or it's other services that other teams are building. So you end up with this kind of cascading thing where your system or your team controls this portion of the system, and then you've got this exponential growth here on what you're actually responsible for, just because any failures down here in the triangle are going to bubble back up to your service. And that's, again, where service level objectives are really helpful, because you're understanding basically your service's performance, and you're defining what is acceptable and unacceptable for downstream services performance. So then you understand when things are slow, why they're slow, and when things fail, why they fail. And again, just to go over more microservice challenges. So microservices tend to introduce more complexity. Again, we're going from something that's relatively straightforward because it's all coupled into a monolith. It's easy to reason about, into something that's decoupled with lots of distributed parts. So sometimes people say that microservices do make things simpler. And it's true that they do for some things, but they also cause basically a lot more distributed things to think about. So each microservice is independent from another. That means that they basically need to operate independent from each other. And this also can introduce more points of failure. So basically, we're adding more service-to-service boundaries. We're spreading out calls to infrastructure and external services across varieties of places. So now your monolith was like talking to MySQL, let's say, at the start, and then we added a bunch of microservices. All of those services are separately talking to MySQL, right? So we've spread out all of that, and it's no longer centralized. So let's say we're noticing that there's tons of connections, and it's like basically overflowing our MySQL connection pool or something like that. how do we know which service is actually causing that problem? How do we debug something like this? Now, it's not just a monolith talking to that MySQL table. It's all of these different services. So here's some actual examples of really deep systems from our platform. Basically, I'm showing you real examples from Lightstep of some of our customers. Obviously, the names are blurred out and everything here. But this is a service diagram that's generated from tracing data. And you can see here at the top, this is the service that I queried for. And look at all of these dependencies. It's pretty crazy. It looks like a giant spider web. But essentially, we've got our service here, and then we've got all of these downstream services that this service relies on at some point or another. And the tracing data is bubbling that up. So this is where observability really comes in handy. I don't think any human is expected to actually understand all of the relationships in a graph like this, but sometimes we do need to debug it, right? Because things can fail anywhere in this graph, right? There's all these different points of failure that could happen, and maybe we don't need to understand this up front, but we do need to understand it when we're debugging and trying to identify critical issues and performance problems. And here's just another example. This is actually a little bit more typical I've seen, but same thing. We've got like our service here that we queried for. Then we have some upstream services that rely on our service and downstream services as well. So service diagrams like this can actually help you understand more what services are depending on you and what services you depend on, which can be useful for planning. But again, it becomes even more useful when something is going wrong. So now I'm going to get into some strategies, essentially, for how to leverage observability. I'm using the word APM, but really I mean like modern APM or observability tools. So de-risking for code complexity is a category here. As I mentioned before, basically, in order to create a successful migration, you need to understand which code paths and dependencies in the monolith are going to be migrated over to the microservice. And accounting for some of these code paths can actually be pretty difficult, and this is where tracing really comes in handy, because it helps you visualize in your monolith which code paths are going where and help you see any ones that you missed, basically. Because we're separating all of that functionality out, we don't want to miss anything and cause failures. We can also use observability to verify when code paths can be deprecated because they're not being called anymore and they're no longer serving traffic. So this kind of helps with that. For example, if you're using feature flags, like that whole feature flag problem where you don't know when you can get rid of the feature flag because you don't actually know when that code path is done being called, for example. This is where observability can really help. Finally, observability is really helpful in deployment of that new service. Basically, it can help you figure out if the functionality isn't regressing, and whether that performance is actually better or worse before and after a deployment. And Lightstep in particular has a really great tool for this. We call it our deployments page, and essentially you can actually see where your service got deployed, and you can compare before and after the deploy, your error rate and your actual latency. So it can be really useful, especially when you're iterating all the time in developing your microservices. And you can also basically compare the performance over time between your old monolith and the endpoints there and your new service and the new endpoints. So de-risking for performance regressions. Again, observability is really, really helpful for these kinds of things, identifying bottlenecks. So we want to identify bottlenecks in the monolith that we want to fix in the microservice. How do we do that? This is where keeping track of basically where time is being spent in your monolith can be really useful. And you do that using things like tracing because they show you where the complexity is being spent and what the critical factor is here that is causing your request to take long, for example. And it helps you figure out which things we want to fix, essentially, in the new service. And it also, observability can help you figure out if you introduce any new bottlenecks, where those bottlenecks are. Even if you're not going to completely optimize for them, it's important to understand where they are so that you then know when you're debugging or something like that, where to look first. So collecting throughput, error rate, and response time requirements that the new microservice needs to support. This, again, goes back to that whole service level objective thing. So we want to identify basically our service level objectives for the new microservice, and we want to identify that same exact flow for the third-party services and external services we need to rely on. And then from there, we can alert on these and figure out when the problem is within our own new microservice and when the problem is within our external infrastructure or third parties or other services. De-risking for external dependencies. So basically, we want to enable developers to see how the new service code is performing in real time as it's being built. So as soon as a developer creates code calling a new external service, and this is like in the ideal world, they should be able to see whether that external service is responding, whether that call out to the external service is successful or not, and basically how long that is taking. So this actually really increases developer velocity if they can see this right away and verify that things are working as expected or not. And this can be kind of hard sometimes in a local environment. Sometimes we can't run our whole code base and everything that we rely on locally because it's, for example, just too big and too many services to run locally. So we want to have observability there so that when a developer creates a new call to anything, really, they can verify that that call is successful across the network and it's doing what they expect. Wrapping the new service in easily debuggable and understandable service level objectives. So I know I keep coming back to this over and over, but I think it's super important to define these objectives because it gives everyone a clear picture of the current state of the world, both during the code migration and after the migration has been completed. And it really gives developers the confidence to be able to move on to something else if they know that their service is performing correctly and if they know that it'll be easy to figure out what went wrong if it decides to not perform correctly or if a downstream service goes down or whatever. Really, the slide isn't exactly about de-risking external dependencies. It's also about building up developer confidence to increase velocity and get that velocity that everyone talks about when they're moving to microservices. So that is the end of my spiel. A lot of this is really just my opinions upon seeing all the different migrations that I've seen in the past and helped with. And working at Lightstep, I've seen a lot of this firsthand, and now I build tools to help solve a lot of these problems. So please do check us out. We have a pretty cool interactive demo. It's lightstep.com/sandbox. Feel free to play around. And also, feel free to connect with me and ask me more about these things. We're happy to talk to you about all of these distributed system problems and how observability can help, even just using open source tools and not Lightstep specific ones. So thanks so much for listening. And now we can get to Q&A.
All right, wonderful, Stephanie, thank you. So just a reminder to the audience, if you have any questions for Stephanie, please type them in the Q&A box now. So our first question is asking, I believe this came in on slide 14 and 15, but it's asking, is there a tool that you are using to visualize microservice dependencies?
Yeah, so we use ourselves actually for this. So that's kind of what Lightstep is meant for. We're based on tracing. and we collect tracing data from your system and then display our dependency map, essentially. We call this a service diagram, but really it's a dependency map on external systems and other services, and we build this up by collecting tracing data for your service. There's definitely other tools as well that can do this, kind of, but really the key here is leveraging the tracing data because we can actually see which services are having problems by doing this. So in this diagram, you can see some of these little dots here are red. If I were to zoom in, you'd be able to see it a little more clearly, but this is just a screenshot from our product. Each of these red dots could be services that are failing that's downstream from yours. So this is where tracing in observability really comes in handy because you can actually just see which services could have affected your service. But yeah, the tool is Lightstep.
Awesome. Next question is asking if you have any tips for service mesh deployment and best practices.
Service mesh. Yeah, so we actually recently did a service mesh deployment at Lightstep for our API gateway layer, essentially using Envoy. And basically, when you're using a service mesh based on Envoy anyway, it's pretty easy to collect tracing data for that. So Envoy actually has in its configuration a way to turn on tracing pretty easily, and then you can actually get a visualization of that service mesh. And you can also do that for things like Nginx. I believe there's other integrations out there for Ambassador and Istio. But I think the tip there basically is to leverage the built-in observability tools for those service meshes to understand basically whether they're working correctly or not as you're migrating to that new service mesh or configuring it. Because that tracing data will be really helpful. It'll show you where the requests are hitting the service mesh and not hitting the end service that they're supposed to and things like that.
All right, perfect. During your presentation, you used the term APM, and someone is asking if you can explain what APM is a little bit more.
Sure, yeah. So APM means Application Performance Monitoring. There's so much jargon these days in tech. So people also call that observability nowadays because it's considered more modern. APM is a little bit more old school, I'd say, but it's also the term people tend to recognize more. It basically just means an application performance monitoring tool, so New Relic, Dynatrace, those are APMs. And Lightstep's kind of like an APM, but it's built for a more modern infrastructure like microservices.
Right, perfect. We have another question about APMs, and they're asking, what APM do you use? Sorry if they missed it.
Oh, yeah. So we use Lightstep, actually. So we basically have our deployment set up so we can actually use ourselves to debug ourselves. It's kind of like a little bit meta. But Lightstep is an observability tool, and we do emit tons of tracing data for ourselves all the time. So we use that for debugging and keeping track of our metrics and latency and all of that.
Right. Next question here is asking, what is the difference between Lambda and serverless? Is Lambda the coding construct? Yeah, so that's a good way to put it. Basically, serverless is a framework for writing Lambda functions, and the Lambda itself is just a piece of code that is stateless that runs. So AWS Lambda is like basically the standard there for that, but basically you load up that function, and that's your Lambda function. And then you can use serverless to actually deploy it to the cloud or hook it up to other things. So, for example, if I load up my Lambda function into AWS Lambda, I could also use serverless to generate the template to make that
function call my database or accept an API call, things like that. So serverless is kind of like the framework around the Lambda function.
Perfect. This next question is asking, what tech stack do you use with Lightstep for microservices?
So yeah, Lightstep actually is all written in Go mostly, and we use Go microservices, so that has worked out pretty well. And then we also use Envoy for our service mesh. What else? We use, for backend systems like databases, we use Banner, GCS. We're all on Google Cloud providers, so that's why we have Google things and MySQL. But yeah, that's pretty much our tech stack. I don't think it's too fancy or anything.
All right. This question is asking, how does your tool compare with Azure Log Analytics and App Insights?
Okay, so I haven't actually used Azure before, but I would say that just based on my general knowledge of cloud providers and how their monitoring works, it tends to be pretty high level. So you get to see like system level metrics on your container, and sometimes they have some kind of like tracing sort of along with it, where they'll give you like a diagram of the call stack as it's going from your containers that you've deployed over to your other pieces of infrastructure in the cloud. So what I would say there is it's kind of missing a lot of context probably. So the great part about tracing is that you get a lot more context and detail into which calls are failing, how often they're failing. For example, if only 1% of your calls are failing, like what if you want to see the traces for that 1% of calls? Picking out outliers and things like that is really one of Lightstep's hugest differentiators, since we do that for you, so that it's a lot easier to actually use it as a full-fledged tool rather than just getting some high-level insights.
All right. What is the best way to avoid duplication fields and tables in database design for microservices implementation?
Can you repeat that for me? Sorry. I feel like I missed a little bit of it.
Oh, no worries. What is the best way to avoid duplication fields and tables in database design for microservices implementation?
This is an interesting question. So we're actually designing some database tables right now for our microservices. I'm trying to think of how we avoided duplication there. I think sometimes with microservices, you have to make a lot more tables actually to avoid the duplication and keep all the relationships. So sometimes you might need to make a table with only 2 columns just to maintain the relationship between all of your new tables, and that's okay. So I think my tip there is like the more tables, the better in order to avoid duplication.
All right, awesome. We have another jargon question here. What does SLO stand for?
Yeah, so SLOs are service level objectives. People like to call them SLAs or SLIs. So essentially all of this is service level objective, alert, or indicator. And what these are basically goals where you define how your service behaves, and that way you can basically monitor this and also give it to other teams so they know what to expect from your service. So if I make a new service and I want to surface to everyone else what they can expect performance-wise, I'd have service level objectives or alerts on basically different key parts. So for example, let's say my error rate is going to be less than 5%. And if it's greater than 5%, then I'm going to alert you because I failed my service level objective. And then if for example, I have an SLO on an external system. Let's say the third-party payment service, referring back to one of my slides. Let's say I want to alert if the third-party service is taking longer than 2 seconds to respond for 1% of the requests. That's another service level alert based on an objective where I want my third party to respond faster than that. So really it's just like kind of wrapping goals around how your service communicates with other services.
All right, perfect. This question is asking, does it integrate with VS Code?
I think you're talking about like whether Lightstep integrates with VS Code. I don't believe we currently do, but I'm actually totally interested in hearing more about how you would think this would work, because that sounds like a pretty cool integration. But I don't believe we do today.
All right. This next question is asking about your comments on integration testing and the fact that it's harder with so many moving targets. Do you have any comments on that?
Yeah, it's definitely harder. I totally agree. I think even we've experienced that as well. Integration testing with so many different endpoints and so many different services can definitely be annoying. One thing that I will say is that we actually have a lot of integration testing on the front end that's enabled us to catch basically gaps in our system on the back end where we don't have enough integration testing. So we actually have a great webinar that we did recently with Cypress. So I think you can look it up. It's like Lightstep and Cypress, and that's actually from the team that I'm on, where we have a lot of integration testing done on the front end that mimics user behavior, and that way we can basically rely on those tests as like our final tests that will definitely always catch if something is wrong, because we're testing basically in a way that like how a user would use our system, and that has really helped us a lot with integration testing.
Great. This question is asking, are the monitoring daemon agents for Lightstep's tools non-invasive on the performance side and small footprint on memory-wise?
Yeah, so we definitely always define, or basically we define goals for all of our tools, and our tracers specifically are meant to be totally non-invasive and low overhead. That isn't to say if you were to send, like, let's say 3,000 traces for one request every time on your service, there isn't going to be overhead. Like, there's definitely going to be overhead if you do something weird like that, but in general, they're meant to be low overhead, and they do drop data if they can't keep up with the load, just to keep that small footprint. So we have both tracers that run and require you to modify your code to make those run, and then we have actual agents. We call them special agents because we're trying to differentiate from the old style agent that was a lot more heavy, such as New Relic's agents. And those agents are super lightweight and basically make it pretty painless to add tracing and things like that to your services, because they just wrap your process and then emit that metric data for you.
All right. Next question is asking, how do we generate reports that need data from multiple microservices? Do we write another service for this?
So let me think about this. How do we generate reports that need data from multiple microservices? So I think you're referring to, like, basically a service that needs to do context gathering from other services. And I think that's kind of like an architecture pattern. So you can definitely have another service just for collecting data from other microservices and then aggregating and writing reports based on that. And I've seen that pattern before, and I think that's basically what you're referring to. So yeah, I guess my answer here is like, yeah, write another service for it. basically, even though that might be a little bit of overhead. Yeah.
All right, great. Do you have agents that monitor your agents?
Yeah. They're not exactly agents. They're tracers, basically. We have like tracing data that emits from our agents, but we don't have that on for if a customer is running our agents. That's only for like internal load testing and things like that. We have a configuration to turn that on if we're debugging something.
All right, awesome. Well, Stephanie, I think that's all the questions that we have for today. Do you have any closing thoughts that you want to leave the audience with?
Yeah, sure. I mean, I would just say I'm always open to more questions like this, or if you want to compare notes on architecture or have like a hard to solve problem or something. I love helping people and teaching people, and sometimes I also get to learn from questions like that, and I can, bring in other people from Lightstep, because we all love to talk about distributed problems and microservices. So please definitely reach out if you have more questions on LinkedIn, and also take a look at our sandbox if you want to see all the cool stuff we're building here at Lightstep and how it can help you.
All right, wonderful. Well, thank you so much, Stephanie, for being with us and sharing your expertise. And thank you also to the audience for attending today's webcast, which was sponsored by Lightstep and presented by adtmag.com. This concludes today's webcast. I hope you have a great rest of your day, everyone.